Hello everyone, welcome back to this channel. So today we are going to study about NumPy array in Python. Now before diving deep, tell me one thing. There was already so many built-in data types in Python. Then why NumPy array? Okay, now understand. Python was always a very easy, simple, having lucid syntax. So it was always kind of popular. But there was a problem with Python. Like while we studied the data types in Python, we saw that data types contained heterogeneous data. And secondly, they always contain the address instead of that value directly. So because of these two reasons, Python was very slow. Now the NumPy array solved this problem. How? First of all, it contains homogeneous data, only the numerical values, no other values. Like you cannot store string or other types of data. That increased its speed. Secondly, it directly stores the value, not the address. So the execution speed was increased. Okay, so beforehand, Python was simple, easy, popular, but a problem, that is the problem with the speed. Now NumPy array came and it has solved that problem also. That's why NumPy array is so popular in data science world. Okay, now let's understand what are the things we can do using NumPy array. See first to use that array, you have to import the package. So I have import numpy as np means np is just a nickname. You can give anything. It's like conventional that we give np. Okay. Now I have to run this one. Then the numpy package is imported. Now this one is like creating a numpy array. The syntax is np. You can write numpy also. We don't want to write that big name. That's why we have used np. Now np dot array, in the bracket you have to write the number you want to give. This is like d type float. I have given float. If you give nothing, then let me show you first. If I run this one, then an array of 1 2 3 will be created. Fine. This is what is known as numpy array. Okay, now suppose I want to create some float data types, so I can write d type equals to float. Then this will be float 1.2.3. Fine. So this is the way you can create any numpy array. Next, by using the arange function, np.arange 1 to 15. That means 1, 2, 3, 4, 5, 6. The numbers will be generated. Now I have written, just let me show it first. What will happen? An array will be created from 1 to 14. The last one is excluded. Now suppose if I reshape it with 2 comma 7, then what will happen? Let me show you. 2 means 2 rows. 1 row, 2 row. 7 means 7 column. See 1, 2, 3, 4, 5, 6, 7. So what has become? It has become 2 rows, 7 column. You can write something else like suppose 3, 5. Then what will happen? See, the problem is that now we have 14 values, but we are trying to give it a shape of 3 comma 5. 3 into 5 means 15, but here we have 14 values. That's why it is showing us as an error. So what we can do? We can write like 7 comma 2, 7 into 2, 14. Then we will have 7 rows, 2 columns. We have to reshape it as in a way that it contains 14 number. Okay, now suppose I write 16. Then I have 15 numbers. So now I can save. Now if I try this one, this will show an error. Because I have 15 numbers. So it cannot save it in 7 2. But if I write 3 comma 5, then it will be 15 number. We can write 1 comma 15 like factors. Okay, simple. Reshape means reshaping the array. That's what we need to learn. Next one is, suppose I want to take all those numbers starting from 0 to 10, but there is a gap of 2. Then this will become 0, 2, 4, 6, 8, 10. Okay, every alternative number. You can do 3, then what will become? 0, 3, 6, 9. Okay, so it is just creating a range but with a step value. Simple. Like list, we have studied these things in list also. Next one is linspace function. That this one will be linearly spaced. Like suppose 0 to 1. I want to give 5. That means within 0 to 1, it will give me 5 values having linearly spaced. Let me show you. See, there is a gap of 0.25, 0.25, 0.25, 0.25. So you can see there are 5 numbers having linear gap, that is here 0.25. So if you want these types of array, you can write linspace function. Fine. Now suppose I want to create an array which will contain all 1. Now we can write np.ones. Ones function means it will give us the values where all the values are 1. So suppose I write 3 comma 5. Anything. So what will happen? 3 rows, 5 columns. First one is rows, second one is column. 1 means it will give us value 1. Similarly, why I want all of them to be zeros. So instead of ones, I have to write zeros. Here you can provide anything. Okay. Next one is random.random. That means I don't want to give any value. You select any random value. See here, 3 comma 4, 3 rows, 4 columns, any random value. You run it many times, the values will change. See, notice any value, the values will change. Okay, because it is generating some random numbers. Next one we will study dimensions of an array. Dimensions of an array means here you can see that the array is two dimensional. 1D array, 1D array. This is in another array. So this is a two-dimensional array. Now let me show you. See, this is showing that this is a two-dimensional array. What is 3? This is the column. 1, 2, 3. So there are 3 columns. The array is like that. Let me show you. It is like 1, 2, 3, like this. Here we have 4, 5, 6. Okay. You can see this is an array. Okay. So shape is 2 comma 3. 2 rows, 3 columns. Clear? Now how can I reshape it? By using the reshape function. If you reshape, then it will be simply reshaped. Like if you use reshape function, it will be reshaped into 3 rows, 2 columns. See, 3 rows, 2 columns. 1 column, 2 column. 1 row, 2 row, 3 row. 3 rows. Fine. Now suppose I have an array of 1, 2, 3, 4, another array of 5, 6. And I want to concatenate them axis wise. Let me show you how it happens. First, I have 1, 1, 2, 3, 4. 1, 2, 3, 4. See, I have this array. I can show you 1, 2, 3, 4. Next one is 5, 6. Next one is 5, comma 6. Fine. Now what I want to concatenate them. But how? I want to concatenate them row wise. That means I want the output to become 1, 2, 3, 4, 5, 6. So it will become like this. So we have to write np.concatenate function array1, comma array2, comma axis equals to 0. 0 means it will concatenate row wise. Let me show you. Clear? 1, 2, 3, 4, 5, 6. Okay. Concatenate function you have to use and you have to pass axis equals to 0. That's all. Now suppose I want to add in a different way. Like I want to add 1, 2, 3, 4 and I want them to be added like this 5, 6. Now tell me how can I do this? I am adding them column wise. How can I do this? To do this, first I have to change its shape to this way like 5, 6. This is known as transpose of a matrix. When the matrix is transposed, rows become columns, columns become rows. So I have to first transpose the matrix. Okay, now check how I will be doing this. So first I have to transpose this. Now this matrix is transposed. So it has become like this. Now I have this one and I have this one. Now if I add them, concatenate them and I write axis equals to 1. Because 0 means it will be added row wise, 1 means it will be added column wise. Now this will be concatenated into this one. This one. Now let me show you. Clear? So you can concatenate in two ways, row wise or column wise. Fine, no issues. Now suppose I want to split the array. First I have created an array where I have taken 10 numbers. Now I just want them to be splitted. Like I want in the first row to hold 1, 2, 3, then 4, 5, 6, then 7, 8, 9, 10. This way I want to split. Now see here what I have done. I have split it after 3. So what will happen? After 1, 2, 3, it will be splitted. See, this is the first subarray. Next, 7. 7 means after 4, 5, 6, 7 is printed, now it will go into the next line. 9 means after 9 is printed, it will go to the next subarray. So 8, 9 is printed, now it will go to the next subarray. Fine. So it will, you can split the array by giving any particular number. Then the number up to that number will be printed, and then the next line will start. The next subarray will start. Okay. Now tell me one thing. Why 1, 2, 3, 4? How we have achieved this? You remember the enumerate function? We made a complete video on enumerate function. It just adds the index value. So for I comma subarray in enumerate, that means with every subarray, I will be added. The index position will be added. Okay. Now see here, I have given I plus 1 because I want the index position to start from the 1. Otherwise, it will start from the 0. Fine. Now see this one. Element wise operations. I have first created an array 1, 2, 3. Second array is 4, 5, 6. Now what I want to add them like 1 plus 4 to become 5, 2 plus 5 to become 7, 3 plus 6 to become 9. Then what we can do? We can just write the add function. Then this one will be added. Every element of the arrays will be added with each other. Let me show you first. See here 5, 7, 9. Fine. Now suppose I want to add all these numbers. I want 1 plus 2 plus 3. Then I will use the sum function. Sum of a, that means 1 plus 2, 3, 3 plus 3, 6. See the output? Sum of array a equal to a 6. Fine. Now we can apply statistics also, like if I want the mean, then v dot mean will give us the mean value of the array. 4 plus 5, 4 plus 5, 9, 9 plus 6, 15. 15 divided by 3 equals to 5. See, 5.0. Now what is the minimum of A? Minimum value of A, 1. Maximum of B, 6. Okay. So these are simple operations we can do using NumPy array. Now see next one. Dot product of two arrays. Here 1, 2, 3, 4, 5, 6. Do you know how to do the dot products? Let me show you. First 1, 2, 3. Next one is 4, 5, 6. Now the rules is that first tell me the shape. 1 into 3. 1 row, 3 column. What is the shape? 1 row, 3 column. Now do you think that multiplication is possible? No, because the rule is that this number and the starting number will be same. So this one will not be possible. So what we can do? We can transpose this matrix to this form. 4, 5, 6. Now what is the shape? Now the shape is 3 into 1. 3 into 1. Now see the ending value 3, starting value 3, both are same. So multiplication is possible. Clear? Now how to do the multiplication? 1, 2, 3. Fine. Next 4, 5, 6. Okay. Now the rule of multiplication, if you don't know, concentrate here because it is kind of important and confusing for some people. If you don't understand, then only. So you have to follow these rules. It will go in this way and it will go downwards. Fine. So I will take the first value 1 into 4. So I will write 1 into 4. Fine. Plus this one 2 into 5. So I will write 2 into 5. Fine. Next plus, sorry, this is a plus symbol. 3 into 6. So we will write 3 into 6. So 4 plus 10 plus 18. So 14 plus 18. So the value result is 32. Fine. Let me show you. Okay. Clear? So this is the way dot product is done. Fine. Now here it is showing transpose of 2D matrix. We have already learned transpose means the row will become the columns, the column will become the rows. Let's do it. Okay. So if I transpose 1, 2, 3, you tell me the answer. Okay. 4, 5, 6. And now I will transpose the matrix. Transpose symbol is given by this way. So what will happen? Simple. No worries. This one will come this side. This is the row becomes the column. So first I will write 1, 2, 3. Nothing to be confused. This one will become downwards. Second row, this one will start from the second column. So 4, 5, 6. Clear? So what happened? See, this is the column that has become a row. This is the row that has become a column. Okay, no confusion. Just take this one, put it in this way. Second one, put in this way. Third one, put it in this way. Okay, the matrix will be transposed. Let me show you. This is the original matrix. This is the transposed matrix. 1, 2, 3, 4, 5, 6. Clear? Okay, now the next one is determinant of a matrix. Now how to get the determinant? Let me show you. 4, 7, 2, 6. Like 4, 7, 2, 6. This is our matrix. Now the rule is that you have to, let me show you why this way first. A, B, C, D. Now determinant of matrix means this one will be multiplied. So A into D minus this one will be multiplied. B into C. Okay. So AD minus BC. Fine. This is what is the determinant. So here 4 into 6, 24 minus 7 into 2, that is 14. So what is the value? The value is 10. You get how to get the value of determinant of a matrix? So the value will be 10. Let me show you. Fine. Now tell me one thing. If you get something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then how will you do the determinant? Simple rule. First you take this one. When you take this one, then you just simply don't consider this one and this one. Just forget about them. Okay. Now the same rule. This one multiplied by this one minus this one multiplied by this one. So I will write 1 into, be very careful, 5 into 9. So I will write 5 into 9. Fine. Minus 6 into 8. So now it will become 6 into 8. Done. Plus. Now, now I will consider 2. I will take this one, 2. So what you have to do, just delete this one. Delete it. Fine. Let me write first 1 and then that was 4. Now I will take 2. So I will write here 2 into. Now what will happen? Just corresponding column and rows will be deleted. Forget about them. What is left? 4. So 4 into 9. See here. 4 into 9 minus 6, 7. So 6 into 7. Fine. Done. Now plus. Now let me erase this one. Okay. Now take this one. 3. So I'll write 3. Now delete the corresponding rows and columns. Corresponding rows and columns. Forget about them. So what is left? 4, 5, 7, 8. So 4 into 8. So I will write 4 into 8 minus 5 into 7. So minus 5 into 7. Now simply calculate the whole thing. So you will get the determinant of 3D matrix. It's simple. Whatever the dimension is, you have to just delete the corresponding rows and columns and calculate the part. Okay. So here you can see this is the determinant of the matrix. Now you can do one thing. You just calculate this one, write this one here and check whether you are able to solve this or not. Okay, but in while doing the machine learning project, you don't have to calculate all these things this way. Okay, you just have to write the functions. But you should know what is happening in the background, like how it is calculated. Otherwise, you will not be able to think something of your own, right? But the fact is that you don't have to calculate because calculation is done by the function, and for everything a function is written over here. All we have to do is that we have to use them while they are required. Okay, so you can see that this is such a strong library and we can do so many things by using Python. Okay, so as of now, what we have done, we have just imported it, created an array, different kinds of array, linearly spaced by generating random values by 1, by zeros. We have seen what are the dimensions of an array, how can we resave, how to join arrays by row wise or column wise. Okay, and what are the operations we can perform like addition, sum, different kind of statistical operations. We have done what is a dot product, how to transpose any array. Okay, and we have also seen that how to get the determinant of a matrix. So we have done many things, but a lot to do. See, I have also written a blog here. There, everything is written in an organized manner, and we are going to learn all these things. Next class, we will start generating random values. You can refer to this blog. This is completely free, available on Medium. You just can click the link and see all these things. Okay, so we have already done some part, and from our next class, we will do other things. Okay, bye. Happy learning. Hello everyone, welcome back to this channel. So today we will continue our last class, that is learning NumPy array. If you have not seen the previous video, please watch that first. Okay, let's start today's class. First, I want to generate some random values. So I want an array which will have 3 rows, 2 columns, and all the numbers will be randomly generated. Okay, now in that scenario, I have to use random.random function. And I have to provide the same. Then see, it will give me an array, 3 rows, 2 columns, and all the numbers are randomly generated. But suppose I want these numbers to follow standard normal distribution. There are different types of distribution, but this distribution, the standard normal distribution, means that it must have mean value of 0 and standard deviation of 1. Now simple same here, but the function is random.randn. Okay, now if I run this, again I will get some values which have mean 0 and standard deviation 1. That means these values are following standard normal distribution. When you will do machine learning project, you will come across where you may need this kind of arrays, so you can create by using these ready-made functions of NumPy. Fine. Now suppose I want some normal random integers, then what can I do? I have written say 2 comma 3, and now the function is random.randint. Randint means it will generate integer values but randomly. Okay, low limit, I have just provided some limits. Low limit means it will start from 1. High limit plus 1 because the last one is excluded. So I want it to be up to 10. And size means whatever I have provided, that I want 2 rows, 3 columns. Now let me run this one. See, these are all integers but randomly generated. And all of them following the rules. Low limit 1, high limit 10. See here. So within 1 to 10, all the numbers are randomly generated following the same. Okay, so you have learned three functions: random.random, random.randin, random.randin. Fine. Now let's understand some trigonometric functions we can do using NumPy. First, how we can convert an angle to radians. Let me show you first. Suppose I draw a circle. Consider this as a circle, please. Now, these are the radius. This is a radius, this is a radius, this radius. Now tell me, what is the angle value? That is 90 degree, or we can say this is pi by 2. What is the value for this one? Same, pi by 2. What is the value for the next one? Like this one, pi by 2. What is the value for this one? Pi by 2. So if I take this total one, what is the value? That is pi, because pi by 2 plus pi by 2, 180 degree. Now what is the value for this one? This one is also pi, that is 180 degree. So you can say that this is 90 degrees or pi by 2, total 180 degree, but the complete circle, this is pi plus pi, that is 2 pi. Fine. So now let's see this one. First, I want to calculate sine of 90 degree. Like I want to calculate sine value of 90 degree. Okay. Now you cannot directly put the degrees. Instead, you have to convert it into radians. And these are the radians value. Okay. Now suppose I write 180 degree. This is degree equals to pi. No doubt with that. You can see here this is 180 degree. So this is equals to pi, because 360 degree 2 pi, 180 degree pi. So I can write 90 degree equals to pi by 2. So I have converted the angle into radians. Now I want the value of sine of pi by 2. Okay. Now see how we can write this in Numpy. Here I have written angle in radians. You can write anything. Then I have written 90 degree. I want to calculate sine of 90 degree. First, I have to convert it into radians. So I have converted the 90 into radians. Here the radian value is stored. Now I have written the function np dot sine inside angle in radians, the radian value. Now if I calculate the sine value, see it will show me sine of 90. You know the value sine 90, that is 1. What is the value of sine 0? It's 0. See here, we will check. 0, it is converted in radian, np dot sine of radians, that means 0. So I can get the value of sine 0, that is 0 0.0. Clear? So you understand this one? This is the what happening in the background, and this is in a single line. You just calculate these things by using numpy array. Fine. Now value for inverse functions. You know inverse functions? Inverse functions mean, suppose I want sine inverse of which value I have taken here? 1. Okay, 1. 1 means 90 degree, we have just checked. So we want sine inverse of 1. How to calculate it mathematically? First we consider it as theta. We consider sine inverse equals to theta. So we can write sine of theta equals to 1. If it comes here, it will go this side. No issues. So we want the value of theta which is equals to 1. For which value of theta it is equals to 1? We have just seen also, but you should know also that this is 90 degree. So theta means simply 90 degree. Now if we convert it into radian, this will be pi by 2. Check, I told you here, this one 90 degree angle, pi by 2. So this is the radian value. Now suppose what is the value of pi? 3.14. We all know these things. Now divided by 2. So we can get 1.57. Fine. Let me run this one. See here I have taken 1. I want the value 1.57. Okay. So which function do you need to do these things? Arc sine. Simple, put the arc sine functions and give the value you want to know. Then it will give you the radian value. Fine, no issues with that. If you want to check with something else, 0, what will be the answer? Sine inverse of 0. Let me show you this one too. I want sine inverse of 0. That is what our question is. Now we consider that this is equals to theta. So we can write just simple sine theta equals to 0. So if sine theta equals to 0, that means which value of theta is equals to 0? That is 0. Simple. So let me run this one. The answer is 0. So by using this function, you can get the inverse also. Inverse of any. Simple. You put cos, you put tan, see the value, and then check whether it's working or not. It will work. These are simple single line numpy functions. Fine. Now you can convert the angle to degrees. We have already learned how to do this. So you just put any value, then convert it into degree. Okay. Now see here, I put 0 here. That's why the value is in degree 0. If I give 1, then it will be 1.57. Here you can see that the value is in degree 90 degree. So sine 90 equals to 1. Fine. Now let's do the next part. That is some statistical functions also we can apply by using numpy array. Here see, I have generated a random array. We have already learned that random.randint starting from 1 up to 100. Last one will be excluded and I want 10 as a size. Now let me show you. See here 10 numbers and randomly generated. Now if I want to calculate the median value of the array, I'll just write a function called median. It will give me the median value. Now how can we calculate percentile? Percentile if we want to calculate, I have to use this function. And if you want 25th percentile, 75th percentile, 50th percentile, 100th percentile, just by writing this function, you can get the percentile of the data set. For discovering the outliers, percentile will help you a lot. Okay. Now next, the last one, array comparison. I have taken two arrays, 1 to 3, 1 to 4. Now what I want to compare them. Just check whether they are equal by giving the equal function. Whether they are not equal by giving the not equal function. Greater, greater equal, less equal. Okay, simple use this function, pass these two array, and then if you try to print, it will show you the result. Let me show you. This is very, very simple. It will give you some boolean values, whether equal or not equal. Here just I have checked np dot equal array 1, array 2. So 1 1 equal, 2 2 equal, 3 4 not equal. That means true true false. Clear. Here you can check less equal. So 1 1, that will be false. Sorry, less than or equal. So 1 1, that is true because they are equal. 2 2 equal, 3 4, 3 less than 4, yes, true. So in every case this is true. The same way you just check for others also. So you can just simply check each element comparison using numpy array functions. Okay, so we have completed the basic things of numpy array, but there are many other functions. But if you understand the basic, then you will be able to apply others also. Okay, bye, happy learning. Hello everyone, welcome back to this channel. So today we are going to study about Pandas library in Python. Now first of all, to do any machine learning project, we need data because data is the main input. We are going to work on data, clean the data, find the patterns and predict. Okay, that's what machine learning does. Now, how can we collect the data? It can be done in many ways. Like in Pandas, if you have heard about scikit-learn library, that is a very famous, very popular library. Okay, in that library, developers have already kept some data sets, some real life data sets, some toy data sets. So we can simply download them and can use them in our project, can research on those data. Simple, we can do that. Or we can just simply create our own data, or we can collect from different websites by web scraping, or websites directly provides you the data. So that way also we can collect the data, but the data may be in JSON format, the data may be in Excel file, the data may be in CSV format. Okay, now these data sets must be converted into data frame on which we can apply the machine learning algorithms. Okay. Now the question is, what is a data frame then? Data frame is simply a tabular structure, a two-dimensional tabular structure. We can say it's simply a table which must have rows and columns and data are organized properly. That's what is known as data frame. So first, in whichever format we have the data, we have to convert it into a data frame. Then only we can apply the machine learning algorithms. Okay, now the question is, then what is the pandas job? The pandas job is to create the data frame and many other functions also. Okay, so the first job is you have to convert your file formats into a proper data frame just before starting the project using pandas library. Okay, now for using pandas library, we have to import it. How? Import pandas as PD. Okay, why PD? It's just an alias. You can give any name. Okay, it's like nickname. Okay, so after you import, now you can convert it into a data. Now first we will see that how we can download anything from scikit-learn library and can work on that. Now we will download the dataset from sklearn library. So we can write from sklearn dot datasets import load iris. Okay, load iris dataset is based on iris flowers. Their length, width, these are given datasets, and you have to find which type of species is this. Okay, that's what the dataset all about. We will explore more. Okay, now let me start. So now first we have downloaded the dataset as of now. we have to keep it in a variable load iris. This one will just download the data set. Okay, you can give any name. This is just a variable name. I have given iris. It is loaded. Now let's check what is there in iris. First I will write type function. Type function, you remember, it gives us the data types. So you can see this is sklearn.utils.bunch. Bunch simply means it has lots of data. Okay. Okay. So you can see this is not a data frame yet. We will convert this into a data frame. Okay. Now suppose before that, if I just want to check what is there in the data set. So I can write iris dot data. Can you tell me what I'm trying to do here? This is slicing. You can remember slicing. The first one giving nothing means start from the initial. Fifth means up to 5 rows. Okay. See here. First rows 0th, 1, 2, 3, 4, 5. So I have just sliced it from the data set. This is not a data frame. You can see. So these are the things given. Sepal length, petal width of the flowers, and our job is, that is our target is to find which type of species is this. Okay, now let's see what are the feature names. Feature names simply means that what are the column names. Okay, that is what is known as feature names. That means sepal length. This one is sepal length in centimeter. Sepal width, next one. Petal length, this one. And petal width. Okay, these are the column names. So these are here feature names. Okay. Now what are the other things we can see? Like we can check the shape of the data. Iris dot data dot shape. Shape is an attribute. This is not a function. That's why we have not given the brackets. First one is row, the next one is column. So it has 150 rows, 4 columns. 4 columns we can already see, and it has 150 rows. Okay. So we have just explored what is there inside this iris dataset. Okay. Now our job is to convert it into a data frame. Then only we can apply those machine learning algorithms. Okay. I can directly convert, or I can convert in this way. First, I write df features. I'll show you both the ways. Okay. PD dot data frame. Data frame. This one will convert the data set into a data frame, into a table, two-dimensional table having proper rows and columns. Fine. Inside this, we have to pass attributes. Data means iris.data. That means take those data from the iris, keep it in df features dataset. Comma, it must have some columns. So columns equal to iris dot feature names. I have already shown you what are the feature names. This one. So I want them to be the column names. Okay. Now let me run this. How can I check? By giving the head function. So if I write, see, you can see now. Data, these are the data. These are the feature names which are used as columns. Data means all these things are kept in this df features data set. So now we have a proper data frame on which we can apply the algorithms. Okay. And our data set has rows and columns. Fine. Okay. Now, if you remember, for supervised learning, we have label dataset. So, our dataset may contain a label or may not contain. Now, in this dataset, we have labels. So, what types of learning is this? This one is supervised learning. Anyway, that's not our topic for the day. So, we will add the target column. df underscore, sorry, target equals to pd dot data frame data equals to iris dot target. Here the data is what is written as target in iris. That is what I will take it as the data. And what are the column names? I have only one column. So one column name, that is target. Fine. Now let's see what happens. So I have two data frame. One is df features data frame. Another one is df target. Let me show you what is there in df target. So if I write the head function always shows us the first 5 rows. Now our job is to determine the types of the iris flower. Okay. So this is our output. Now we will concatenate both of them. How can we do it? Simply by writing df equals to, I will give this data set as df. Df is like conventional, everyone uses this. You can give any name you want. Okay, you can write anything. Now I will write df equal to pd dot concat. Concat is a function which is used to concatenate. Here, what are the things we are going to concat? Two data sets. First one we have created df features. Second one we have created df target. Fine. Now write axis equals to 1. Why axis equals to 1? Axis equals to 0 means it will be added row wise. Axis equal to column means it will be added column wise. Done. Now let's see what is there in df. So df dot head. See here. Although both of the data frames have been concatenated. So you can see these are the this is the data set. We have rows, we have columns, we have the data, we have it labeled output as well. Okay, so we can apply any supervised algorithm on this data set. Fine. Now let's see what are the other things we can see. Like if I write df.tell, these are the functions you will be using while doing different types of project. Df.tell means this will be showing us the last 10 rows. Let me show you. Df.save. This will give us the rows and columns. 150 rows, 5 columns. So you can see these are the last 5 rows. So if you give tail, it will show you last 5 rows. If you give head, it will show you first 5 rows. By default, it gives you 5. If you want more, you can simply mention that. It will give you 10. Here target is 2. That is different kinds of iris flower. Okay, fine. Now what are the other things we can do? Like we can write df.info. Info means it will give us the complete information about the dataset. Here you can see total 5 columns. It is showing us sepal length, sepal width, petal length, petal width. What are the non-null values? 150 non-null. That means there is no missing dataset. And these are in float values. But this is in integer. Float means decimal point. Integer means discrete 1, 2, 3, 4. Float means 1.2, 2.3. You can see decimal values. This is integer values. Okay. So simply we can get complete information from df.info. Now suppose if I write df.describe. Describe function will give us the statistics of the dataset. Here every column is numerical column. So they provide count, mean, standard deviation, minimum. Okay. So from this you can have an overall idea about the dataset. That also you can do using df.describe. Okay. Fine. So we have many data sets on scikit-learn library like Wine data set, Boston housing price data set, many real data sets and many toy data sets. So your job is to simply download a data set and try to follow all these steps. Okay, if you face any problem or if you have any question I have missed to explain, then kindly ask in the comment sections. Fine. So this is the way we can simply download the data set and we can work on that. But most of the time we'll be working on external data sets. So now we have to see how we can download them and how we can explore those data sets. That we will be doing in our next part. Okay, bye, happy learning. Hello everyone, welcome back to this channel. Today we are going to continue Pandas library in Python. In our last class, we learned that how to download any data sets from sklearn library and then convert them into a data frame. Now in this session, we will see how we can convert different kinds of data formats into a data frame so that we can apply the machine learning algorithms. Okay, we are going to do many examples. Now start with this one. Here I have created a list of list. So now our job is to convert this data into a data frame. Okay, now how can I do it? Same process, the data frame function by using pd.dataframe pandas short form. This one is the data, that is the values, and now columns means the name of the columns. Here I have written name, age, city. Name will be the first column, age will be the second column, and city will be the third column. Now if I try to print this, then the data frame will be printed. See, it will be, this list of list will be converted into a data frame. I'm sorry, I have to run this pandas as pt. Okay, see, this is converted into a data frame. Okay, next one, see, this one you can see that this is a dictionary, but list of dictionary. Same, I want to just convert them. Here I don't need to provide the column names. It's already given like name, age, city. So I can just write pd.dataframe data. Now if I run it, this will be converted into a data frame. Okay. So you can gather data in any format. Now first your job is to convert them into a data frame. That is the main crux. That is the main usage of pandas. Okay. Now see this one. Here I have created an array using Numpy. Numpy library can be used to create any array. So see, I have just created an array and I have same kept it in data. Now I want to make it a data frame. How can I do it? By using data frame data. Here columns and names are not provided, so I can give column name. These are the column names. You can give another column names also. Okay, as per your ways. This is not fixed. These are the string. They, you can see these are kept in a quotation. Okay, now if I run it, then the numpy array, this is a numpy array converted into a data frame. Now you can apply algos on that. Okay. Suppose I have any CSV file or Excel file and I want to work on those. If you have seen my project, then you have already experienced. Otherwise, let me show you. See, this is a data set. You can see. Now my job is to upload this data set in Colab, convert it into a data frame so that I can apply machine learning algorithms. Fine. This is, you can see this is an Excel format. Or if I want to open it with Notepad, now you can see that this is a CSV file. Why CSV? This is comma separated value, full form of CSV. See, this there is comma after every values. Okay, so that is why this file is not CSV file. So your file can be in CSV format, can be in Excel format, can be in JSON format. It doesn't matter. You can simply convert them into data frame using Pandas library. Okay. Now suppose first what I have to do, I have to upload the data set. So you can go here, click here and upload files. So I have kept it in download. Okay, see here this one is getting uploaded. Once it's uploaded, you can use it. So I can write df equal to pd dot read csv. If you are uploading an Excel file, you can write Excel. Okay, it's simple, nothing. Whatever the format is, you have to write it here. pd dot read and the file format. Here I have to put the path. How can I write it? You can just click here, copy path. You just keep it here. Okay, you have to keep it in quotation. Fine. Suppose you are working in Jupyter, then also no issues. If your folder is in desktop, go to the folder, right click on the folder, copy the path and put it in the Jupyter. No problem, there will be no issues. But sometimes we make a problem with front slash and backslash. I face problems many times. So if you are facing any problem like it is unable to find, then you may check that whether you have given the correct slash or not. Okay, just be careful with the slash. Okay, now you can see that it is already done. Now, same way, do you remember df.head can help us to see what is there in the data set. Okay, this is the same data set we have just seen. So we can simply upload this in read underscore CSV, read underscore Excel, read underscore JSON, in whichever format it is, and you can simply work on that. Now you can apply df.info, df.describe, df.save. There are many other functions in Pandas. You can apply all those things in a data frame. Fine. So this way you can create a data frame also. Study about different types of functions. Here I have just created a dictionary and I have converted it into a data frame. Dictionary means you don't need to provide the columns because already there are keys. Keys will be used as column names. Fine. Now here I have just sorted the values. How? By age. I want the data frame to be sorted. So I can write sort underscore values by the column name, by the column age. Now if I run it, first one is the data frame, the original data frame, this one, 25, 30, 22, 28. Next one you can see the ages are sorted, 22, 25, 28, 30. Fine. So you can just simply sort the values by giving sort underscore values. Okay, fine. Now if you want, you can do other things also, like you can apply df.info, you can apply df.head, you can apply df.tell, df.describe. Whenever it's converted into a data frame, you can apply whatever the functions you have in pandas as per your necessity. Okay, next understand duplicates function. Here you can see I have written Alice, Bob, Charlie, Alice, David, Bob. So things are repeating like Alice, Bob. Okay, they are repeating. I want a clean data set where there will be no duplicates. So for that, first I have to convert this data into data frame. What I have done here, as it is a dictionary, no column names are required. Next step is find the duplicates. How can I find the duplicates? By using the duplicated function. This function will give me those values which are duplicates. Let me show it to you. See, these are the values which are duplicates. Okay. Alice, Bob, Alice, Bob. Alice 25 New York, Bob 30 San Francisco. These are existing in the dataset two times. So I can write df equal to df dot drop duplicates. To check the duplicates, I have to write duplicated. To drop the duplicates, I have to write df underscore drop duplicates. Now suppose if I want to print df, see, Alice, Bob, Charlie, David. No duplicates. Alice, Bob, Charlie, David. Alice and Bob, second time, they are simply removed. So I am getting a clean data set. Okay, so this is the way you can remove duplicates. Fine. Now suppose I want to check whether there is any null value or not. How can I check that? df dot is null. Let's see. See, it is showing me the boolean values. False means there is a value. It's not null. Same. So there is no null value. Here you can see no null value. That is why it is showing me as everything else false. Okay. Now suppose instead of is null, if I provide not null, then the opposite one. Not null means to check whether the value exists. Yes, in every column there is a value. So this is giving us true. So is null, not null, exactly opposite, but doing the same things like finding whether there is any missing value or not. Why do you need to find anything missing or not? To achieve a good accuracy, your data must be clean. So it should not contain any missing values. Missing values can be deleted or can be replaced with some other values. There are some methods, but those things we will learn while doing EDA part. Okay. Now let's understand another function that is as type. See here, I've created a data, name, age, salary, a dictionary, converted it into a data frame. Now if you check D types, so it will show you, just let me show you. It will show you that this is a data frame, name is an object, age is an object, salary is an object, D type object. Object is kind of string. Here everything you can see in a string format. These are also in string format, written in quotation. So that's why these are treated as object. Okay. Now I have converted into a data frame. Okay. Now what I want that age is in a string format. But I want it as a numerical value. Salary same. I want to convert it into a numerical value. So I can simply change the data type by using as type function. If you write as type function and you pass in which you want to change it, like I want to change it into an integer, so I can simply write as type integer. So it will be changed into integer. Salary will be changed into float. Float means decimal values. Now if you check the D types, you can simply see that name is object because we have not done anything with name. Age we have changed it in integer, so in 64. Salary we have changed it into float, so float 64. Okay, so you can simply change the data type also after you have converted into a data frame. Okay, so after you convert your data sets into a data frame, then you can clean the data using different kind of functions. Fine. Here I will tell you how to convert anything to date time format. Here there is the data which is containing date and value, but dates are in string format. So if I check the D types, it will show us as object. Date is an object. Okay. Now our job is to convert it into datetime. Simple. You have to use two datetime functions. Simply call the function and pass the data frame on which you want to apply. Like we want to change the date into date time. So we have written df date. That means within this data set, on this date column, this will be converted to date time. Fine. Now if I just check what is the data type, it will show us date time object. Okay, fine. Simple things. Just practice once. Okay. Next one is a correlation matrix. Correlation, if you have seen my project, you have already experienced it. Correlation means a relation between two columns. Like, uh, suppose if I study for a long time, I'll get good marks. So these are kind of positive correlation. There is a relationship between two columns. If one is increasing, another one is also increasing, then it is positively correlated. If one is increasing, but another one is negatively decreasing, so relationship between them is negatively correlated. Depending on the relationship, we can find the correlations. So for that, we have to use CORR function. This is the data. I have just converted it into a data frame. And now if you simply call the correlation function CORR, then you can get a correlation matrix. Okay. Now let me show you. This is just a correlation matrix. The value is between -1 to 1. It shows that if A increases, B decreases. But if A increases, C also increases. A and C positively correlated, but A and B are negatively correlated. Simply understand the concept. What is correlation, and we can use them wherever we need to know what are the relationship between different columns. Okay, so that we can find the patterns from the data set. Fine. Now see next one. You have a data set, like you just want to convert this data set into Excel file and you want to save that. That's what your task is. Now how can you do it? I have just taken a data, converted into a data frame. You may have a ready-made data frame also. Like we have that data frame. So what you have to do, you just want to convert it into an Excel file. Now first you have to give the file path. File path means where you want to save the file. If you want to save it in desktop, just go to your desktop, create a folder where you want to keep, right click, copy path. Just put the path here. That's what you have to do. Okay. Next one is you have to write df dot to Excel. To Excel means this will be converted into an Excel file and will be saved. Okay, here provide the path. This is the path. You can directly put the path here, or you can write here and write the variable name here also. So it will just simply convert it into an Excel file. Now if you run it, this will be saved as an Excel file into your desired path. Okay. Same way if you want, just write CSV to underscore CSV. So it will be converted into CSV file and it will be saved. Fine. Now see this one. This one is just I have created a pivot table. Okay, first see here. Here you can see that score of Alice in math, score of Bob in math, score of Charlie in math, score of David in math, score of Alice in physics. So you can see that the data is a bit haphazard manner. I want a good summary of the table. I want to convert it into a pivot table. For that, I have to write pivot table function. DF, that means the data frame. I have to provide values, index, column names. Let me show you first. You can see here. So on the basis of subjects, the column will be created. What are the subject? Math, physics. So math will be one column, physics will be one column. Fine. Index is name. You can see this one is known as index. The first one, the first column. So index means name. Alice, Bob, Charlie, David. Okay. And then put the score as values. These are the score. So you have to put the score accordingly. Okay. That's what we instructed, and now our data frame is ready. Okay, so if you just want a good summary of any data frame, you can convert it into pivot table. Okay, so we have almost completed basics, in fact more than basics from pandas, but we are going to learn more while doing exploratory data analysis part. Okay, so bye, happy learning. Hello everyone, welcome back to this channel. So as of now, we have already completed Numpy and Pandas. Now we are going to start Matplotlib library. This is mainly used for data visualization purpose. That means when we have the data sets, we can simply create graphs, plots, charts of different columns on the data set. Those will help us to understand the hidden patterns in the data. We can interpret the data very easily from these graphs or charts. Okay, so for that purpose, we are going to use Matplotlib library a lot. There is one more library like seaborn that is also used for data visualization purpose. First, we will learn Matplotlib, then we will study about seaborn. Okay. Now, first of all, let me tell you one thing, that is what are the types of data. We have already made a video. Here also I will give you a brief. First of all, it can be divided into two types. Number one is numerical data. Number two is categorical data. Numerical data means numbers like 1, 2, 3, 4, 5, your roll number. That is a numerical data. What is category? Like your gender. It may be male, maybe female, maybe others. So that is a categorical data. Okay. So simple numerical means number, categorical means that's a category. Now depending on whether a column is a numerical column or categorical column, we are going to create the plots that will help us to understand that which plot is best suited for which types of columns, which types of data. Okay, like if the columns are numerical, then scatter plot may work better. We will learn all these things while studying those things. Okay, now see here, these are the basic plots we can do using Matplotlib library, though it has many other wide range of libraries. By using, you can create different kind of graphs, other graphs also, but these things we are mainly going to use in our projects a lot. First we will get comfortable, then we will study all other things, related things also. Okay, so in our next class we will start with 2D plot or line plot. There we will take many different types of data sets and we will learn how we can create different kinds of plot, how to analyze from those plots, how to derive information from those plots. Okay, because that's what you are going to share with others and you can give them suggestions like what is the problem and how it can be improved. Okay, so you have get an overall idea of Matplotlib. From the next class we will study line plot. Okay, bye, happy learning. Hello everyone, welcome back. So let's continue our Matplotlib class. Okay, first I will download all the libraries. Import Numpy as np, import Pandas as pd, import Matplotlib dot pyplot as plt. Plt same nickname, you can give any name. Okay, now let's do a simple line plot. Okay, first I will create a data set like x equals to 10, 20, 30, 40, 50. Y equals to 100, 200, 300, 400, 500. A simple toy data set. Okay. Now I will create a plot between x and y. So I have to write PLT. PLT means this one, calling the Matplotlib library. Here there is a function called plot. So PLT dot plot, first x column, comma, y column. Now if I run it, it will show us a plot. Okay. Now there is no description about the picture, so we can add those by giving plt dot x level. You can write anything. Here I can write x axis. Depending on the column name, we can give any meaningful name. Okay, here also y axis. No problem. Now if I run it, see x axis, y axis. Now I can give a name to the picture also. For that I have to write plot dot title. Title means the name of the picture. We can write line plot. Okay, now if I run it, see it will be showing line plot. Okay, now suppose if I want to decorate this, I can give a color like color equals to red. Look, the color has been changed. Okay, we can change the line style also. Line style equals to dotted. Then see what happens. Okay, so you can change the style also. Okay. Now if I want, I can give a line width equals to 10. But for that I have to make it solid. Now if I give line width, then see the width of the line has been increased. Okay, so these are the things we can do. Next, we can do plot dot grid. See, a grid has been created. This makes things more attractive and more meaningful. You can easily understand that here 10 pointing to 100, 20 pointing to 200. Okay, now if you want to show the point more prominently, you can just write marker equals to plus. Line width is too much, that's why it is unable to understand. So give 2. Now so you can see that there are plus symbols. Make it 1. Now you can see the marker. See here 10, 100. Next point 20, 200. Next 30, 300. 30, 300. 40, 400. 50, 500. Okay. You can give other things also like oh, so you can sorry, this is not recognized. I think we can give dot. Okay, see. So dots you can give. Okay, so you can give marker also. You can change the line width. You can change the line style. You can give a color. You can give a name also to this. You have to write label equals to just give X. Now suppose if I name it, you can't see any change. For that you have to write plt dot legend. Now see what happens. See here you can see X. Okay, so it's kind of single plot line. Now suppose you want to create a multiple line. Create one more y column. Y equals to like 200, 400, 600, 800, 1000. Now suppose if I plot this, just copy, paste. Here I am plotting with x and y2. X means x column, y means y2 column. Change the color, make it blue. Line style, line width, let them stay same. I have to change the label. See, now if I run it, you can see X means this one, Y means this one. Okay, so you can give some meaningful name here in the label, so you'll be able to understand what it depicts. Okay, now one more thing, if you are using some other like PyCharm or something other editor, then you have to write plt.show. Here it is not required in Google Colab, but if you can't see the graph where you are working, you have to give this one. Main purpose is to show the graph. Okay. So this is the way we can create simple line plots and multiple lines also we can plot in the same picture. Okay. Now suppose if I write plt dot figure fig size equals to 6 comma 6. Now see what happens. And now I give 16 comma 6. See the figure size has been increased. So if you want to just increase the figure size, you can simply change it. Like if I give 12 comma 10. 12 comma 10. 12 means length, 10 is the height. Okay, so this way you can just change the size of the picture as well. Fine. Now next plot a sine curve. Okay, for that I have to make a data set. So I will use Numpy library lean space function. Can you tell me about this function? We have studied this in our Numpy class. This will create total 100 values within a range from 0 to 10, and all the values will be linearly spaced. Okay, meaning having similar gap. Okay, now create y equal to sine of x. Now write plt dot plot x comma y. Oh, sorry, I have to write np dot sine. Okay, now if I plot, see sine curve will be plotted. See, you can see. If you want the cos curve, same way you have to write y1 equal to np dot cos of x and plot, give it y1. Now run it. See, sine curve, cos curve. but give them some name like plt dot x level x and plt dot y level. You can give any meaningful name. Okay. For the full picture, plt dot by title, plt dot title, sine curve and cos curve. Okay, you can create tan also. Try to do this. Now if I run it, you can see the names. Now suppose if you want to change line style, you can just give line style equals to dotted. Oh, I'm sorry. Line style equals to dotted. See, this one is dotted. Now give a label name. So I have to write label equals to any name, sign. Here also label equals to cos. Now if I run it, there will be no change. Can you see any change? No. To see the change, you have to write legend function. So write legend. Now see, it is visible. Now if you want to change its position, then that also you can do by using LOC equals to give left. Now if we run it, okay, there is nothing left. You can use these things like best, upper right, upper left, right, lower center, center. Let me give center. Let me just show you. See, then it will be placed in center. If you give nothing, it will find the blank space and then it will set accordingly. Okay. Now, if you want to give marker like this one, that also you can give. You can change the line width also. Now, suppose if I give line width equals to 20, not 20, that will be huge. Give 7. Now, if I run it, see. Okay. So, you can decorate in your own way. Okay. Now, do the tan one also. Plot one more np dot tan x, then plot that too, and label also. Okay. Now, next do one more. Suppose I create a column years equal to 2015, 2016, 2017, 2018, 2019, 2020. Now if I write stock price equals to 100, 200, 300, 400, 500, 600. 1, 2, 3, 4, 5, 6. Total 6 values in both places. Now if I want to plot them, plt dot plot x years, y stock price. Now let me run this. Sorry, here plt dot plot. Okay. Now if you want to give, just put sorry, put a marker equals to, see, you can see 2015 100 values, 2016 200, 2017 300. Okay, so you can find a relationship between the columns from this graph. You can understand that with years it has been increased. So a simple graph can give you the information very easily. You have to see here and you have to notice, but instead of that, if you just look at the picture, you can understand that the stock price is increasing and linearly increasing. Okay, so for communication also, these images are very important, these graphs are very important. Okay, so we have understood what is a line plot. In our next class, we will study about scatter plot. Okay, so bye, happy learning. Hello everyone, welcome back to this channel. So today we are going to continue our Matplotlib session. Okay, we have already completed line plot. Now we will understand what is a scatter plot. Okay, let me first describe you what is a scatter plot. I have two columns, number of hours and score. And I believe that the more number of hours I study, the more marks I will get. If I study for 2 hours, my score will be 40. If I study for 6 hours, my score will be 80. Okay. Now if I study for 10 hours, then my score will be 99. Okay. So there is a relationship between two columns. If this one is increasing, score is also automatically increasing. Now we will make a scatter plot of this data. Okay, first I will draw x-axis and y-axis. In the x-axis, I will keep number of hours. That is, we can say it is an independent variable. In the y-axis, I will keep the score, which is a dependent variable. So, score is here dependent on the number of hours. Okay. So, first one, 240. Like, I can create a scale here. 2, 3, 4, 5, 6, 7, 8, 9, 10, like this. Okay. So, this may be 6. Here, it may be 10. Okay. This side also I have to create a scale of score 40, 60, 80 like this. So suppose this one is 40, this one is 20, this one is 60, this one is 80. So how can I create a scatter plot? 240. So x is 2, y is 40. So this is a okay. Next one 6 and 80. So 6, 80. So this is going to be our second point. Next one 10 and 99. So this is 10, 99 may be upside. So I can say this is a point. So this is known as a scatter plot. So why scatter plot is used? To find the relationship between different variables. Okay. So scatter plot is mainly used for bivariate analysis. Second, to find the relationship between variables or columns. Okay, here you can see that we can find the relationship that if the number of hours is increasing, score is also increasing. So the x-axis, this is known as independent variable, this is known as variable dependent variable because score is depending on this x-axis on number of hours. So this is what now we are going to do with Python. So we can write x equals to 2, 6, 10. Y equals to 40, 80, 99. Now, can you tell me what will be the code? Plot dot scatter x comma y. Or if you want, you can just write number of hours and score. Okay. Now if I just copy this, first one is for x axis, second one is for y axis. Now if I click it, then it will be sorry, I can write import matplotlib dot pyplot as bld. Okay, now if I run it, see scatter plot is drawn. It's like as we have drawn. Okay, you can see 240 this is a junction, 80 680 and 99 10. Okay, so this is what is known as scatter plot. Can you tell me what is the difference between the line plot and the scatter plot? Can you tell me? A simple difference. Here every point is connected through a line, but here you can see that the points are not connected. If I want to make it a line plot, I will just write plot instead of scatter. Now see, can you see? Okay. Now if you just give a marker here, then you can see that if I give star, then okay, only these are connected by line. Scatter means these are not connected by line. And one more important point is that this is mainly used for numerical column. Both of the columns must be numerical. Okay, you can plot on categorical, but this is of no use. Okay, so mainly it is used for numerical columns and to find the relationship, whether positively correlated or negatively correlated, or we can say correlation. Okay. Okay. Now see, last one we did this one, years and stock price. Stock price is increasing each year. Now if I try to convert this to a scatter plot, how can I do it? You can tell me now. Instead of plot, I have to write scatter. Now you can see this has become a scatter plot. So you can provide marker here also. Okay. You can change, you can give it a plus. Okay. And you can change accordingly. Okay. Now let's draw the sine curve. This one. If I copy this one, I will do a scatter plot of sine curve. See, I have copied this. First, let me delete these things. Let me check once. Oh, sorry, I have to numpy as np, import pandas as pd. Now let me run. This is a line plot. Now I will change it to scatter. I have to change here. Scatter. Here also. Scatter plot. Now let me run. See, it is a scatter plot. Okay. Simple difference. The points are not connected. In fact, here also we have drawn like this. This one by changing the line style dotted. Okay. So you can simply draw a scatter plot. You can change this marker also. Okay. Simple difference. Line plot means every point is connected. Scatter plot means points are not connected. Okay, all other things are same. I already explained in last class. Linearly spaced, we have taken 100 values, taken their sine values, cos values, and plotted the sine curve and cos curve. Okay, no problem. Now see, we can figure with different axes also. To do that, I'll write fig equals to plt dot figure. That means figure will be plotted. Sorry, plt, not o. Okay. Next, ax, I'll take an axis fig dot add axis ADD AXES. Now inside this I'll write 0 comma 0 comma 1 comma 1. It means this one will start from left, extreme left. 0 means will start from the extreme left. Next 0 means it will start from the exact bottom. And 1 means height will be full height and width full length. Okay. So this one is 0 starting from the extreme left, starting from exactly bottom. Height is width is 1 and height is also 1. Now suppose if I run it, let me show you. See, the axis has been changed. So you have created a two-dimensional scatter plot. Clear? Now if I want to create a three-dimensional scatter plot, now how can I do it? Let's do. Create a figure, plt dot figure. Now I have to create axis. Here I will write plt dot axis. Inside this projection equals to 3D. Showing bigger. Okay, it has been changed. Fine. Now suppose if I change it to plasma, then see what happens. Oh, I'm sorry. Uh, Maybe it's not in capital. See the color has been changed. You can give very this. So you can change the colors also. Okay. There are many other color maps. C map means color map. There are many other color maps. You can choose accordingly. Okay, so we have plotted a 3D scatter plot. Fine. Do the next one. I'll create a new data set. 1, 2, 3, 4, 5. Y equals to 10, 20, 25, 30, 35. And colors equals to 100, 200, 300, 400, 500. I'll explain everything. No worries. Sizes equals to 20, 50, 80, 200, 500. Fine. Now I will first plot scatter plot on x and y. Now let me show you first what happens. X is the x-axis. and y is the y-axis. Scatter plot has been plotted. Now if I write C equals to colors. Now see what happens. Look, colors are changing. It's taking the values of 100, 200, 300, 400, 500, and this is the way the colors are changing. Now I want to change the sizes. So I have written a list of sizes. Now I will write is equals to sizes. This parameter takes the sizes. See, sizes are increasing in this order, so it will also increase in this order. Clear? So it is following these patterns. Colors are following this pattern, sizes are following this pattern. So you can pass arguments in this way also. Now one more argument. Alpha equals to 0.5. Notice very carefully the colors. Okay, it will change. Transparency has been changed. Now suppose if I give 0.1. Look, it's not almost visible. Okay, so if you want to change the transparency, if I give 1, now see, they are vibrant. Okay, so you can change the transparency as well. Now you can give the color map. Last time we also gave. Let's give it. Okay, now let me run this. See, the color also you can change. Okay, now suppose if I want to plot this color as a bar chart, plot dot color bar. Now see what happens. The color bar will be printed. Okay, 500 means this color, 450 this one, the lowest one 100 this one. Okay, so the color bar is also printed. Now print this, then now see this technical writings are also gone. Plot dot show means it will be completely focused on the graph only, nothing else will be written. If I don't write it, then see some here it is written like matplotlib dot color bar. To remove these things, if you are doing in other editors, you must write plt dot show. Fine. Okay, now we have understood how to do with external dataset. Now suppose I want to do with some internal dataset. So I already told you in Pandas session that how we can download and work on that. Now I will download one. This is in seaborn library. We have not learned that. As scikit-learn library has datasets, seaborn also has some datasets. So we can simply download it from here. So I will first write I'll sns dot load underscore dataset. And the name of the dataset is tips. Okay. So the dataset will be downloaded and it will be stored into tips. Now see what is there in tips. Just print it. You can see that it is a data frame. Okay. What are the columns? Total bill, tip, sex, smoker or not, which day they came, whether they had dinner or something else, and how many people were there. This is a small data set. This dataset is already there in C1. And now I want to do a scatter plot on total bill and tip. So I want to see that how they are related, whether tips are increasing with the bill or not. So I want to make the total bill as independent variable, tip as dependent variable. Okay, so total bill will be in the x position. So let me write plt dot scatter tips total bill, because this is the x value, the independent one. In the y axis, I will write tip. Okay, now let plot this scatter plot. See, you can see the scatter plot that while total bill is increasing, tips are also kind of increasing. Here total bill is less, tips are less. Total bill has increased, tips have also increased. Okay, so you can find a relationship from this scatter plot. Okay, now suppose if I write that I want to include the size also. So I can write s equal to tips size. Now see what is the changes. Now we can see this has become so small. Now if I want to make them big, I can just multiply them with a bigger number. Now see. So you can also check whether tips have been changed with sizes. Big family size means bigger tips, like that or not. Okay, so simply you can find the correlations between the variables. Okay, so these are the main points of scatter plot. Let me summarize the things again. Scatter plot and line plot is similar. The simple difference is that the lines are not connected. Just let me show you. Plt dot plot. Let me copy this one. If I copy and paste it here, see what happens. See, it has become gibberish. So you have to understand when to use the line plot and when to use the scatter plot. Okay, so that is the simple difference. And second one is that scatter plot is mainly used for bivariate analysis. And next point is that you can find the relationship, and it is mainly used for numerical columns. Okay, in the next session we will continue with bar plot. Okay, bye, happy learning. Hello everyone. So let's continue our Matplotlib session. We have already completed line plot and scatter plot. Now we will understand about bar plot. Okay. Now let me first show you this one. Suppose in your classes 40 people play tennis, 60 people play football, 80 people play basketball. Now if you want to show this information in the form of bar charts, then you may represent it in this way. In the x-axis, or we can say the horizontal axis, we will the categorical variables. The tennis player, football player, badminton player. Categorical means that must be expressed in words, or we can say qualitative variables. And in the vertical axis, that is in the y-axis, we will plot the frequency. How many players are playing tennis? 40 people. How many players are playing football? 60 people. So this is what is called frequency. So in the bar chart, we plot categorical variable versus frequency. Okay, now let's plot this using Python. First, let me create a data set. So in sports data set, I'll write tennis, football, comma, basketball. Okay. Now in y-axis, I will plot the frequency. So I can write in your class. So class 1 equal to 40, 60, 80. Now if I want to create a bar plot, plot dot bar, sports, comma, class 1. Now let me run this one. See, this is what is a bar plot. That's what we have plotted. So you can see that 40 people play tennis, sorry, 60 people play football, 80 people play basketball. Clear? So bar plot means, let me write the main points, or which is actually called bar chart or bar graph, used to check the frequency. So it is plotted categorical column in the x-axis versus frequency in the y-axis. Okay, so this is what is known as bar chart or bar graph. Now suppose if you want to change the orient, you can simply write bar age. Then see, this has been changed. So you can plot in this orient also. Now let's understand stacked bar plot. Let me first delete this one. Suppose in the second class, 20 people play tennis, 30 people play football, 50 people play basketball. Okay. Now I want to plot both of these in a single graph. I will do a stacked bar plot. Let me delete this one and create two bar plot. First one, bar 1 equals to plot dot bar sports, comma, class 1. Second one, bar 2, plt dot bar sports, comma, class 2. Okay, now let me first run this one. This is known as stacked bar plot. One plot is stacked on another one. Okay, now let's decorate this one. If you want, you can just change the color. I want to give blue, and here I want to give green. Now see. Okay, fine. Now suppose I want to provide a edge color. So I can write edge color equals to black. See, here an edge color of black is showing. If you want, you can just change the width also. If I write line width equals to 2.5. See, the width of the edge has been increased. Okay, give it a label. That too will be better. So label equals to, we can write class 1. And same way, label equals to class 2. But I have to write plt dot legend. Now see, you will be able to understand that which one depicts the class 1, which one depicts the class 2. So the upper one is class 1, the bottom one is the class 2. Now if you want, you can keep class 1 in bottom also. For that you have to write bottom equals to class 1. So now class 1 is upside, it will be in bottom position. Fine. Do you want to give grid? Just write plot dot grid. Okay. Now if you want to change the line style of the grid, you can write line style equals to, then see what happens. If you want, you can change the line width also. Same process. Right, line width equal to 0.7. These are the parameters. So there are many parameters and you can set them according to your need. Okay. Now suppose I want to plot side by side. So first let me copy this one and paste this. And this is known as group bar charts. Okay. Now first let me delete these two. First, here I will give a position. 0th position for tennis, for first position football, in second position basketball. Okay. Now to do this, we will write index equals to np dot a range lane of sports. So lane of sports here means 1, 2, 3, 3. Now a range of 3 means 3 number will be generated 0, 1, 2. So index is containing 0, 1, 2. Okay. Now write plt dot bar. In the x position, index value 0, 0th position. There tennis will be placed, comma, y class 1. Now provide a var with. Next, label equals to class 1. Okay. I want to give var width as 0.35. Next class, so plt dot bar x here is index plus var width. That means 0 plus 0.35. Second, 1 plus 0.35. For football, 2 plus 0.35. Okay, that is the x position. Y class 2. Next, var width, give a label equals to class 2. Okay, now see what happens. Clear? Now if I want to give a name, I will write plt dot xticks. Here mention 0, 1, 2. Those are the position value. And here if you want to give some manual names, you can write tennis, football, basketball. Okay. And now give a rotation equals to 45. Now see. See here, you can give some manual names. Or if you just want, you can write plt dot xticks inside ticks equals to index plus var width, comma, labels equals to sports. So whatever is there inside the sports list, it will be labeled. See tennis, football, basketball, as it is written here, it will be labeled. Okay. You can rotate also by giving rotation equal to 45. Okay. So we have learned three things: simple bar chart, stacked bar chart, one top of another, grouped bar chart. Okay. This is all about bar chart. It's mainly plot, categorical variables versus frequency. Okay, bye. Happy learning. Welcome back. Today we will continue our Matplotlib session. Okay, we have already understood line plot, scatter plot, bar chart. Now we will understand what is a histogram. Okay, let me first explain you the concept. Here, this represents ages of different people. Okay, now I want to know that how many people belong to the age group of 0 to 9, 10 to 19, 20 to 29, 30 to 39. Now we will visualize this using histogram. Let's see how. Okay, first this is 9, so that means this belongs to 0 to 9. 19, so this belongs to the age group of 10 to 19. 25, this belongs to the age group of 20 to 29. 30, this belongs to the age group of 30 to 39. 6. That means 0 to 9. 23. So 20 to 29 age group. 15. That means 10 to 19. 12. That means 10 to 19. 14. Same. Okay. Now what is the frequency then? 2. Here. 4. 20 to 29. 2. Now 1. Now let's plot this in histogram. First let me draw the graph. In the x-axis, in the horizontal axis, we will keep the ranges. Okay. So you can say it 0, 9, 19, 29 and 39. So 0 to 9, 2 people. So 0 to 9 means the bar will look like this. 10 to 19, 4 people. So if it is 2, then make it 4. Here it is 2. This one is 4. Okay. Next one is 20 to 29, 2. Same height. It's 2. 30 to 39, 1. So let's say this one is 1. Okay. So it will come under this range. So this is what is known as histogram. In the x-axis, you keep the ranges. These ranges are also known as bins. So in the x-axis, in the horizontal axis, you keep the bins, and in the y-axis, you keep the frequency. If you remember, while plotting bar chart, this was categorical variable, this one was frequency. Here, this one is numerical categories, and this one is frequency. Okay, so bar chart or histogram kind of same, but understand the differences. In bar chart, I'll show you that in bar chart there is a gap between every bar. You can see, but in histogram there is no gap. Second one is that in bar chart we plot categories versus frequency, but in this one we plot numerical categories. We create the categories, we create the ranges, we create the bins and versus frequency. Okay. So our main job was to see how many people belong to different age group. Okay. Now let's plot this in Python. I copy this one. Now I will write plot.hist ages and I need to provide the bins. You can provide any bins. Let's say I give 0, 10, 20, 30, 40. Now if I run it, see what happens. 0 to 10, 2 people. 10 to 20, 4 people. 20 to 30, 2 people. 30 to 40, 1 people. Just like as we did here. Okay. So this is what is known as histogram. Okay. Looks like bar plot. There are some differences. Okay. Now suppose if you want to plot stacked bar plot, then what can I do? I have to take one more list. Ages 1 equals to, if I write 9, 20, 23, 33, 31, 12, 15, 17, any number of values. But I have to keep the count same. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Here also 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have to give one more. Okay. Now I have to write plot.hist. I'll write ages, comma, ages 1. Keep it in third bracket. And you have to provide the bin size. So I can write bins equals to 0, 10, 20, 30, 40. Now let me run this one. Now if I run this one, see, but here it is not one top of another. So I want it to be on top of another. For that I can write stacked equal to true. Sorry, true. Now see, it will create stacked histogram. Okay, now you can label it by plt.x label, plt.y label, plt.title, give label name, and you can change the color, you can give edge color, you can change the line width, you can give the grid, you can change the line width of the grid or line style of the grid. Okay, so all of this we have already done before. We are not going to do it here. Simply understand the concept of histogram. Histogram means we are plotting numerical categories versus frequency. So we can see the main objective is to find the frequency distribution. And here we plot numerical categories or we can see bins versus frequency. Okay, so this is all about histogram. Now, one more thing I forgot to tell you. Instead of giving exact numbers, if you want, you can divide it into 5 parts. Then also it will work. You can give any number of bins, whatever range you want to create. You can create 3 parts also. It will be divided into 3 parts. If you give 2, then it will be divided into 2 parts. Okay, as per your need, you can just change it. Okay, so we will meet in our next class. Bye, happy learning. Hello everyone, welcome back. So we are continuing our Matplotlib session. As of now, we have completed line plot, scatter plot, bar chart, and histogram. Today we will understand about box plot. Okay, first let me show you how it looks. Then I will explain. Okay, first let me copy this one. Here I have created a list of edges. Now I will create a box plot on these edges. Okay. Now for that I will write plt dot box plot and inside this the edges. Now see how it looks. Okay. Sorry, I have to import matplotlib dot pyplot as plt. See, this is looking like a box. Now let me first make you understand how it is formed. Then I will explain what are the values you can derive from this image. Okay. First I will arrange them in ascending order. See here, I have already arranged them. Okay. 1, 2, 4, 6, 8, 10, 12, 14. Total 8 numbers. Okay. Now our job is to find these values. Minimum value, first quartile value, second quartile or the median value, third quartile and the maximum value. So here you can see that minimum value is 1, maximum value is 14. Now median means the middle value. Okay, see here total number is 8. So the formula of calculating median is n equals to 8. 8 means this is an even number. Now the formula of calculating median is n plus 1 divided by 2. So 8 plus 1, 9 divided by 2 equals to 4.5. So we have to find the value which is in 4.5th position. How to calculate that one? By averaging fourth values and fifth values. So what is in fourth position? 1, 2, 3, 4, 6. So 6 plus. What is in fifth position? 8. So 6 plus 8 divided by 2 is the median value. Okay, so we can write 7. Simply also you can understand that these are the two middle values. Here also three numbers, here also three numbers. So we have to calculate the average to find the median. If it is an odd number, then a single number will have become the median. Okay. Now we will calculate the percentile. Q1 means first quartile, 25th percentile. Percentile means the total data set is divided into 4 parts, 25, 25, 25, 25. So first 25 percentile is known as Q1. Second 25th percentile is Q2. Next 25th percentile Q3. And next is the max. It's like, let me show you. First 25 percentile, this is Q1. Second 25 percentile, that is 50 percentile or quarter 2. Next 25 percentile, that is 75th percentile or we say Q3. And next is 100 percentile. Okay, so we have to find Q1 and Q3. Now how can we find this? For that the rule is P equals to n plus 1 by 4. Now what is n? Total number, that is 8. So 8 plus 1 divided by 4. So 9 divided by 4 equals to 2.25. Okay. So we have to find the value which is in 2.25th position of the list. Okay. Now how can we calculate this? For this we have to find the value in second position, that is 2. So it will be 2 plus 0.25 into 4 minus 2. So 4 minus 2 means 2. 2 into 0.25 means 0.50. So in total, this is 2.50. Okay. So the value is 2.50. So you can write this one is 2.50. Okay. Next, we will calculate Q3. How to calculate Q3? That means 75th percentile. Now for that, the rule is P equals to 3 into n plus 1 by 4. So n 8, 8 plus 1 9, 9 into 3 27. 27 divided by 4 equals to 6.75. So we have to find the value which is in 6.75th position. Now how can we calculate? First we have to find what is in 6th position. In 6th position, first, second, third, fourth, fifth, sixth. That is 10. So first write 10 plus what is in 7th position? 7th position 12. So we have to do 12 minus 10. 7th position minus which is in 6th position into 0.75. So we write 0.75. So 12 minus 10, 2, 2 into 0.75, 1.50. So we can say 10 plus 1.50. So the answer is 11.50. Okay. So we have got third quartile, that is 11.5. Okay. Now how can we plot this? First, Q1 2.50. So plot here 2.50. Median 7. So this one is 7. Q3 11.5. So it will be in middle of this 11.5. Now we have to just connect this. This is the box we have just seen. Okay. Now minimum equals to 1. So connect it by a single line. Maximum equals to 40. So connect it by a single line. Okay. Now it describes that this portion is 25th percentile. 25% of the data is in this position. Okay. Next one is from here to median, that is 25th percentile. 25th percentile is located here. In total, this one is 50 percentile. Okay. Now next one is also 25 percentile. 25% of the data is located here also. So in total, 25 plus 25 plus 25. In total, this is 75 percentile. Okay, that is what is known as Q3. And the next one is also 25 percentile. So in total, it is 100 percentile. So you understand the concept of percentile. The total data set is divided into 4 parts and each part is 25 percentile. Okay. And the 50th percentile is known as the median value. And if you calculate the interquartile range, that is Q3 minus Q1. That means 75th percentile minus 25th percentile. Exactly this position is known as interquartile range. Okay, this is what is known as box plot. Let's see here. Exactly this one. Okay. Now, if you want, you can just simply change the orient by writing vertical equals to false. Now see, it will look like exactly this one. Okay, so you can see here. Here it is the first quartile, 25 percentile. This is the median value, 7. This is Q3, 75 percentile, and 11.5. Here it is maximum value, 14. So we can just derive from this box plot what is the minimum value of a particular column, what is the maximum value, what is the 25th percentile, what is the 75th percentile, what is the median value. Okay, so if we simply do a box plot, we can get this amount of data. Here also we have understood how these things are calculated in the background. You don't have to do the calculation, just understand the calculation, and all you have to do is to write a line of code and you can get so much of data from this box plot. So this is an univariate analysis done on a single column. Now let me show you one more thing. Just copy this one, paste, and here write notch equals to true. Now suppose if I run it, this way also you can do a box plot. Fine. Now suppose if I write plt.boxplot, so means equals to true. Now see what happens. Can you see a marker? This is the mean value. Mean value means average of all the values. 2 plus 10 plus 6 plus 4 plus 8 plus 12 plus 14 plus 1 divided by the total numbers. That is 8. That will give you the mean value. In the mean value, you can see a marker. Okay. So with all these other values, you can find the mean values also. Now, the main purpose of using a box plot is to find an outlier in the dataset. Outlier means those values which are far from the median values. Okay. Now suppose if your dataset has outliers and you apply algorithms on that, then it may give you some bias result. So first you do a box plot, then you see that whether there is any outlier or not. If it is existing there, you can simply remove this by using some percentile calculation. We will learn those things later. Okay. Now see how we can check whether there is any outliers or not. For that, our data must have some outliers. So let me add some outliers. Like if I add 100, 300. Now see what happens. See here, it is looking so small because there is a value in 100, there is a value in 300. So the dataset is becoming too large and it is showing too small. So our job will be to remove those outliers. Okay, so this way we can plot the outliers as well. This is all about box plot. This is done on a single column, univariate analysis, and it gives you the mean value, median value, minimum value, maximum value, and percentiles. Okay, and this is done on a numerical column. These are the main crux of box plot. Okay, we will meet in our next video. Till then, bye. Happy learning. Hello everyone, welcome back to this channel. We are continuing our Matplotlib session and we have only one thing left, that is pipeplot. So in today's session we will understand what is a pipeplot and how to plot in Python using Matplotlib. Okay. Now first understand what is a pipeplot. Suppose you are new to a city. Now you want to gather some friends. How can you do this? From local clubs and groups, or from community events, from classes and workshops, or from social apps and websites. So by this four method, you can gather friends. So you can get 30 friends from local clubs and groups, 25 from community events, 20 from classes and workshops, and 25 from social apps and websites. Okay. Now suppose if you want to convert them in percentage, then you can write 30 divided by 30 plus 25 plus 20 plus 25. That means the total into 100. So it will be converted into percentage. Here I have taken the total 100. So this one will be the percentages also. 30%, 25%, 20%, 25%. Okay. So 30% friends you can get from local clubs. 25% you can get from community events. 20% from classes and workshops. And 25% from from social apps and websites. Okay. From social apps. Now, if I want to represent this using a pie chart, then it will look like this. It's a circle. Okay. And it is divided into four parts. This one is representing local clubs and groups, the 30%. Here it is community events, 25%. Now, classes and workshop, it is 20%, so bit smaller. And next one is social apps and websites, that is 25%. Okay, so this is in clockwise direction. From this chart, you can understand that how many percentage of friends you can get from which category. Okay. Now, how to do this in Python? Let's understand. First, I have copied all these things. And now if I write plt.py, inside this, I have to mention the sizes. And first, let me show you with the sizes only. Like, let me delete this one. Now, suppose if I run it, see, you can see the pie plot. It's looking same. Now suppose we can't understand anything from here. So we can decorate it by giving labels equals to labels. That means it will take all these strings and will put as labels. Let me show you. Now it is more presentable. Here I can see local clubs and groups, social apps and websites, community events, classes and workshops. Fine. Now suppose I want to change the angle. Then I can write start angle equals to 140. Then see what happens. It is starting from 140. This one is 90. This one is 90. And this one is 140. So from 140 it is starting. It goes anti-clockwise. If I give 180. Now see what happens. See, 180 means the straight line. From here it is starting. Okay. So you can change the starting angle also by giving start angle equals to 180. Clear? Now if I want to change the colors, how can I do it? There is a parameter called colors. Here I can write colors, but here I have to provide the colors. Like suppose I want green, red, maroon, yellow. Now if I run it, see what happens. I have forgotten a comma. I have to provide a comma. Look, you can change the it's four color combination, but you can change the color also. Okay. The first one will take the green, second one red, maroon, yellow. Okay, so you can change the colors also. And you have to pass this in this color parameter. Okay. Now suppose if I want to provide a shadow, I can write shadow equals to true. You can see a shadow. Okay. So these are the way you can decorate. Now suppose if you want to give the percentages, then I can write auto PCT equals to 1.1 if percent. It also starts with percent. Now let me show you. You can see the percentages. Okay. You can give 1.1, 1.0. Here both of the scenario it is same because it's only a single number. Otherwise you can represent like 25.2, 20.3 by giving 1.1. Okay. If you don't provide, you just provide 1.0, then it will be in single digit 25%, 25, 20%, 25%. Okay. Now there are so many technicalities. You can just remove them by writing. You can tell me plt dot show. Now see these things will be gone. Now it is looking better. Okay. Now you can give title plt dot title, and you can also increase the figure size by writing plt dot figure fig size equals to 16 comma 7. Now it will look bigger. So you can change the figure size also. Okay. Now one more thing. Suppose I want to focus on one thing. That I can do by writing explode. Inside the explode function, I have to write 0.1000. Now see what happens. Here also I have to pass the parameter explode equals to explode, comma. Now let me show you. See, if I want to focus on this one, then it can be exploded in this way. It will come out. If you want to do it on something else, suppose on classes and workshops, then here also you can write 0.1. Clear? Now suppose let it stay 0.1, but here I give 0.5. So this way also you can represent your pie plot. Okay. Now let's understand one more thing. Now suppose I write plt dot py inside sizes levels equals to levels, wage drops equal to big width equals to 0.4. See how it is looking. It is looking like a donut. So you can create in this way also. Okay. If you write plt dot show, all these technicalities will be gone. If you want, you can make the figure big. If you want, you can give a title. You can give colors. Okay, so you can do all these things. Okay, so this way you can create donut also. So these are the ways by which you can represent a pie plot. Okay, bye. Happy learning. Hello everyone, welcome back to this session. So as of now, we have completed Matplotlib library, and now in today's session, we are going to revise the concept we have learned. Okay. Uh, you can see the graph. We have learned about all these things. Okay. First, to install Matplotlib, you have to write pip install Matplotlib. This is for the very first time. Once you have installed, you can simply import to use all of its functions. Okay. So import matplotlib.pyplot as PLT. PLT is a nickname. You can give any other name, but whenever you call any function from Matplotlib, you have to use by PLT or by the name you have given. Okay. And now the basic usages. We have already learned about these things in detail. First one is line plot. Line plot means these are data points called markers connected by a straight line. And it is mainly used to show the trends over time or other continuous data. Like it is increasing or decreasing. That is what was line plot. Next we studied about scatter plot. Here scatter plot means it is same like line plot but markers are not connected by line. Okay, each point represents the observation in the dataset and it is mainly used to find the relationship between two variables. Okay, so the difference between these two is line plot is connected, scatter plot is not connected. Okay, next we studied about bar graph and bar chart. This is mainly used to find the frequency and it is displayed by using bars of different heights or different lengths. Similar kind of histogram, but there is a difference. Histogram bars are connected with each other. Okay, so histogram, the data is divided into bins like intervals, and we count how many number of observations fall into each bin. This is also used to find the frequency. Okay. Next, we studied about box plot. Box plot is a distribution data based on a 5 number summary. Minimum value, first quartile Q1 or we can say 25th percentile, median 50th percentile, third quartile 75th percentile and maximum value. So from a simple graph we can find all these numbers and we can even plot the mean value also. Okay. Why box plots are mainly used? To find the outliers. Outlier means those values which are far from the mean values. And those outliers create bias in modeling. So our first job is to find those outliers and remove them. Now to find the outliers, box plot helps a lot. Okay. Next we studied about pie plot. This looks like a pizza where each slice represents a category's contribution. Okay. So we have studied about all these things, we have coded and we have visualized all these things in our last series of classes. Now next we will apply our learnings while doing projects. Okay, bye. Happy learning. Hello everyone, welcome back to this channel. So we are continuing our data science course. As of now, we have completed the basics of Python and also Numpy library, Pandas library and Matplotlib library. Okay, so today we are going to learn seaborn library. Okay, first let me tell you why it is used. It is mainly used for visualization. Can you tell me the name of another library which is also used for visualization purpose? We have studied Matplotlib. Okay, but there are some basic differences between Matplotlib and C1 library. We will learn about all those things, but as of now, just know that C1 has some more advanced features than Matplotlib. Okay, that doesn't mean we can ignore Matplotlib. That has also its own benefits. We will learn about all these things. Okay. Now let's see these are the categories or we can say these are the types we can plot using seaborn library. Okay, relational plot, distribution, categorical, matrix, multiplot and regression plot. We are going to know about all these plots in detailed manner. Okay. Now first of all know that there are two categories of plots. Number one is figure level, number two is axis level. Whenever we plot something, you can see this is a container. This container we can say is a figure and inside the container the graph, the plot that is an axis. So we can use figure level function or we can use axis level function also. Clear? But you can see that here there is one figure but two axes. So within a single figure you can have multiple axes. Okay. So if you want to create an individual plot, you can directly use axis level function. But if you want to create multiple plots, like you want to show the complex relationships, then you can use figure level function. We are going to learn about both of this. Okay. Now first one is relational plot. Relational plot is a figure level function, but scatter plot, line plot, these are the types of relational plot. These are axis level function. So how can I plot scatter plot and line plot? We know these plots while studying Matplotlib. Here also the concept is same. To find the relationship between two variables, we can use scatter plot or we can use line plot. Fine. Now let me show you how it looks. First, let me copy paste. See here. First, I have imported seaborn function. I have given a alias name, nickname, SNS. By using SNS, I am going to call the functions which are in seaborn library. Next, I have also downloaded Matplotlib because sometimes we may use this one also. Okay. And in the seaborn library, there is a data set. The name of the data set is tips. So first, let me show you how it looks. So I have first simply loaded the dataset. Now if I want to see the dataset, then I can write tips. This is a dataset which is already in C1 library. We have just loaded it. Okay. See in the dataset, there are 1, 2, 3, 4, 5, 6, 7 columns. First column is total bill. Second is tip. How much people are providing tip. What is the sex? Whether smoker or not. Which day they came, whether they did lunch or dinner, and how many people came together. So these are the data we already have in the tips dataset, which is already loaded in seaborn, and we have just downloaded the dataset. Clear? Now let's see how we can generate a scatter plot. So sns.scatter plot. Here I have to write x equal to total bill because I want to see what is the relationship between total will and tip, whether it is increasing, decreasing, or even it is not affecting at all. Okay. For that, I'm going to plot a scatter plot. So I have to write y equals to tip. And I have to provide data equals to, data is a parameter where I have to provide the data set. That means I have to mention from where you are going to take the data. Okay, so it is take the values from the tips data set. It will keep total will in the x column, tip in the y column, and it will create a scatter plot. I'm so sorry. Okay, so you can see the relationship between total will and tip. Okay, so this is an axis level function. Now let me show you how it looks if I use figure level function. What is the figure level function? The rail plot. Now within rail plot, I want to write x equals to total will, comma, y equal to tip, data equal to tips. Here I am drawing figure level function. This one. Okay. I have already plotted axis level function by using scatter plot. But now I am drawing a figure level function. I am using relational plot. So relational plot can be of two types. See here. It can be a scatter plot. It can be a line plot. So I have to explicitly mention what is the kind. So here I have to use one more parameter, that is kind. So kind equal to scatter. Now if I run it, clear? The same plot, but it is looking a bit different. Let me show you. Here it is more white, looking like a rectangle, but here it is not looking like a rectangle. It's not that much of white. So this one is figure axis level function. This one is figure level function. Clear? But both of them producing same output. But here I have to mention kind parameter while you are using the figure level function. Clear? Now let's see what is a line plot. Same. Let me just copy this. If I want to apply on this one, then I have to just change it to line plot. Now if I run it, see what happens. Clear. See, if you want to see the relationship using line plot, you can use line plot. In scatter plot, every point is not connected. In line plot, every point is connected. Okay. So here also you can find the relationship. Now you will be able to understand more with some, if you use some meaningful column. Like if I use line plot on is equal to size, is equal to size, y equal to total bill. Now see, I want to see whether it is increasing with size, obviously. Total will is increasing with size. Okay. So this way also you can draw line plot. But if I want to use figure level function, then same rel plot inside this. Let me copy this one. If I copy, I have to mention kind equal to line. Then if I draw this, okay, same. It is more wide because it is an axis level function. This is a figure level function. So by using rel plot, you just have to mention kind equal to scatter or kind equal to line. If I don't provide kind, then what happens? What do you think the output will be? Just because this is by default, this is a scatter plot. Okay, that's why it will be shown the scatter plot. But if you want to mention that it is a line plot, then you have to write kind equals to line. Like here also, if I just don't give kind equal to scatter, the same output will be generated because by default it is a scatter plot. Now tell me, what is the difference if I use the matplotlib function? Can you tell me? Do you remember? There we did not write x equal to total will. We wrote total will, comma, tip. And we didn't need to mention data equal to tips. Okay. But see here, automatically total will is printed. Tip is printed. But in matplotlib, we had to write plt.x level, plt.y level, plt.title. Okay, but here you don't need to explicitly mention the x level or y level. So for writing or for creating a same graph, you have to write less code in seaborn library. Fine. But if you want to change the name, so you can just import matplotlib function, this one, and you can give plt.x level. Let me show you. If I write plt.x level and within this I write bill. Now see what happens. See, X level is changed. Okay. So if you don't provide also, then also the name will be, the by default name will be automatically printed. But if you want to change the name, that also you can do. So you understand the advantages of matplotlib function and the advantages of seaborn function and where and how to use all these libraries. Okay. So we have completed relational plot. We have completed this one. Now let's understand distribution plot. Okay. Now distribution plots is used to visualize the distribution. You can do this using histogram, using KDE plot or using a RAG plot. Let's see all of them one by one. First, histogram also we know. Histogram means you have to create bins and you can perform on single column. First, let me delete this one and let me write it 10. Just see. Bins equal to 10 means the total bill column divided into 10 parts and we want to see that what is the distribution of the total bill. So here this is the range where the bill amount is highest. Okay. By using histogram you can find the frequency. Fine. Now let's understand KDE plot. KDE plot is mainly used to estimate the probability density. We have not studied about probability density yet, but we will learn about probability density while studying probability. For now, just say that you can simply do a KDE plot. KDE plot on a particular column, tips total bill, that means on total bill, it will generate a KDE plot. Set equal to true means simply there is a set, you can see. If I just remove it, sorry, then let me show you, it will be blank. Okay. Probability density is mainly used for continuous variable. Probability is used for discrete variable. Probability density is used for continuous variable. Because in continuous variable, if a number can be like 0.2, 0.3, 0.235, there can be any number. And probability of generating any continuous number is almost equal to 0. That's why instead of using the probability directly, we use probability density. Now it will not be clear because these things we'll study while studying probability. So as of now, you can just simply understand that we can generate KDE plot also. Fine. Next one is RAG plot. Let me show you how it looks. This is a one-dimensional representation. Okay, along a single axis. See how it looks. this one. Okay, so you can see that the maximum bill is generated in this range. Okay, so this is also known as rag plot. Rarely used, but mainly used with other plots. Okay, so we have completed relational plot and distribution plot. Next, understand categorical plot. Categorical plot can be divided into three types: estimate plot, scatter plot, and distribution plot. So, categorical estimate plot can be divided into two types. Number one is bar plot, and one is count plot. What is a bar plot? Let me show you. We have already studied in about bar plot in Matplotlib also. Here I am using day column, total will, and data equals to tips. Same rule, you have to just write sns dot bar plot. Now you see Thursday total will, Friday total will, Saturday total will, Sunday total will. So maximum people come for Sunday. That is normal also. So to find the distribution of categorical data, you can use bar plot. Fine. Next one is count plot. See how it looks. If I run it, this one is count plot. Like Thursday, 60 people, Friday, 20, Saturday, more than 80, Sunday, 75. So this is a count plot. Okay, so you can see the count of observations in each category. Now next one is categorical distribution plot, box plot and violin plot. See, box plot also we studied in details that it is mainly used to show the quartiles. To know the 25% quartile, 50th quartile, 75th quartile, the median value, we plot a box plot. Let me show you. If I just run it, now see, x equal to day, that means these are the days, y equal to total will. So you can see that Thursday, 25th quartile, 75th quartile, this is 50th quartile, this is the minimum value, this is the maximum value. So we can find the 5 values from a box plot. Minimum value, 25th quartile, 50th quartile or median value, third quartile or 75th quartile. Next is the maximum value. And what are all these things? Can you tell me? These are the outliers. Okay, if you have any doubt, you just go to the Matplotlib section. There I described box plot in details, like how it is divided into 100 percentiles and what are the things we can derive from a box plot. Okay, here just understand that if I want to use box plot using seaborn, we have to write sns.boxplot. You can plot box plot using Matplotlib also. Okay, so this comes under categorical distribution plot. Next one is violin plot. Now to see how it looks. Just let me copy this one. If I paste and run it, see, you can see this is a KDE plot. We have just studied density function, and inside this you can see there is a box plot. So violin plot is a combination of KDE and box plot. Clear? Okay. Next one is categorical scatter plot. Now categorical scatter plot is also known as point plot or strip plot. It also displays the relationship between one categorical variable and one continuous variable. See, this is a strip plot. Strip plot, it looks like strip. So Thursday total will, Friday, Saturday, Sunday. Saturday, Sunday fields are more, so you can see. So this is the way you can draw a strip plot. Okay, so we can say that if you want to plot a scatter plot on categorical data, then you have to use strip plot. If you want to plot scatter plot on numerical data, then you have to use sns.scatter plot. It's simple. Okay. Now one more type is swarm plot. Let me show you how it looks. If I just run it, then see it will look like swarm. So this is a strip plot and this is a swarm plot. So it just adds some noise, slightly noise, so that it does not overlap with each other and the visualization makes better. That is what is the difference between scatter plot and swarm plot. Okay. Okay, so we have completed categorical plot, bar plot, count plot, strip plot for categorical scatter plot, swarm plot adds a bit noise so that it does not overlap. Box plot gives us the quartiles. Violin plot, it adds the distribution plot, box plot, and with probability density functions. Okay, but suppose if I want to use the figure level function, then I can have to just write sns dot cat plot. Okay, let me show you this one. If I just copy this one and paste it, let me show you. sns dot cat plot. Here x equal to day. So these are the day. Y equal to total bill. Kind equals to violin. Violin plot I have drawn. Hue equal to sex. So that blue male, orange female, and data equal to tips. Okay. So I have used cat plot. This is the figure level plot. Here if you just change it to box, then what will happen? It will be a box plot. If you just change it to strip, see? If you just change it to swarm, clear? So a single line cat plot. Here you have to just write kind equals to in which you want to get it. Okay. Box plot, violin plot, swarm plot, strip plot, and what are the other two? Bar plot, count plot. Let me show you these also. Bar, clear? Now let's understand one concept, that is faceting. Faceting means breaking down data into different categories. Suppose if I write here column equals to time. See what happens. Lunchtime, dinner time. Different graphs in a single figure. This is possible by figure level function. Cat plot is a figure level function. Here you can plot multiple graphs in a single figure. So this is a figure where you have plotted multiple axes. This is only possible by figure level function. Cat plot is a figure level function. Clear? Now if I write row equals to time, then it will be row wise. Let me show you. See, lunchtime, dinner time. Clear? So you can simply break down the data into different categories by using the concept known as seaborn faceting. This is only possible in seaborn, not in Matplotlib. And in seaborn, you have to use figure level function to do this one. Okay. If I write bar plot and I delete kind equal to bar, and now if I run it, say unexpected keyword argument row. That means in access level function, you cannot use faceting. So as of now, we have completed relational plot, rel plot for figure level function, scatter plot, line plot, access level function. It finds the relationship between variables. Next, we have understood distribution, histogram, KDE, rag plot. Dist is the figure level function. All these are axis level function. Next, categorical. Cat plot is the figure level function, and all these things are axis level function. And if I want to use faceting, creating multiplots, then you have to use figure level function. Else, if you want, you can use axis level function. Clear? In our next class, we will study about all other things. Okay, till then, bye. Happy learning. Hello everyone, welcome back to this channel. Let's continue our C1 session. Okay, so as of now we have completed relational plot, distribution plot and categorical plot. Today we will start with matrix plot. This can be divided into two types, heat map and cluster map. Now you can say that the name suggests it will look like a matrix, like it must have rows and it must have columns. Okay, now let's first understand heat map. Let's read the definition. A heat map displays data in matrix format with colors representing values, and it is used to visualize the correlation between different variables. Okay, so highly positive correlations can be represented by one color, highly negative correlations can be represented by another color. What is correlation? The relationship. What is the impact of one variable if the other variable changes? That is what is correlation. Okay, highly positive correlations means if one is increasing, then another one is also increasing. Highly negative correlations mean if one is increasing, another one is decreasing. Okay. So the effect of one variable on another variable is known as correlation. And to find the correlation, we can use heat map. Okay. Now first download a data set called flights data set. First, let's write import seaborn as SNS. What is SNS? You can tell me. Now download the flights dataset sns dot load underscore dataset because this dataset is already in C1 library. All we have to do is just download the dataset flights. Now let me run this one and let's check what is there in flights. It's a small dataset, number of passengers in each month of any year. Okay, so first we have to convert it into a table which have rows and columns. Then only we can apply heat map. So first we will create a pivot table. Let's see how it looks. Flights underscore pivot equal to flights dot pivot, and we have to give index equals to month. So the index will be month. So the rows will be as per the month January, February, March, April, like this way. Columns will be year. So every year will be a column, individual columns, and values of the table will be taken from the passenger column. Okay, so we have created a small pivot table. Now let's see how it looks. Okay, for that we have to write flights underscore pivot. Let me run this. Clear? So January, February, March, April, all the months are indexed as we said. These are columns and values are passengers. These are known as pivot table. These are so much used while using with large data set. Now we will create a heat map on this. So all these numbers will be represented by colors. Let me show you. SNS dot heat map and under this flights pivot. Okay. Now if I run this, see exactly copy of this one but with colors. Clear? Now if I want to see the numbers also, I have to write a not equals to true. Now see what happens. Uh, this is overlapping. So simple, we have to use fmd equal to d. That means these numbers will be converted to integers. Now it will be more visible. Clear? So we can find the trend from here. Like you can see that in the month of August, July, June, September, in this month, there are more passengers taking flights. Okay, so you can understand the trend. You can also understand that in which month passengers are likely to take a flight. So you can increase the flight tickets accordingly that or decrease. Okay, or you can give any kind of offer. So in these months, maximum people are taking flights. Like in February, people are taking less flights in comparison because this portion is dark. In November also this portion is really dark, so people are not taking flights. So you can decrease the flight tickets to increase the sales. Okay, so these are the basic things we can derive from heat map. That is what is a heat map. Now next one is cluster map. Let me show you. This one is cluster map. It performs hierarchical clustering to organize the data and it groups similar rows and columns together based on their values. Just let me copy this one and if I just paste it instead of heat map I have to write cluster map. Now let me show you. There will be a hierarchical clustering. The rows are clustered, the columns are clustered depending on their types. Here you can see that January, February, November, March. So the order has been changed. So simply we can say that it groups similar rows and columns together based on their values. Okay. So based on the values, it has grouped similar columns. Same looks like heat map, but it is performed on heat map and hierarchical clustering is formed. That is what is done by cluster map. Okay, so heat map and cluster map both comes under matrix plot because both of them look like matrix plot. Okay, clear? Now let's understand the next one, and this is multiplot. Multiplot, the name suggests that there will be more than one plot together. It can be divided into two plot. Number one is pair plot, number two is joint plot. Pair plot means you can understand that there will be pair-wise relationship of every numerical columns in the dataset. Let me first download tips dataset. Then I will show you how pair plot works. SNS dot load underscore dataset site tips, and I have to keep it in tips. Just check it once. Okay, clear this one. We know this dataset. Now I will create a pair plot on tips dataset. Now see what happens. Total will tip size. Three numerical columns. So there will be pair with all of these three numerical columns. So 3 into 3, 9. See here, total 9 plots. Total will tip, total tip, total will size. Tip, total will, tip size, tip. Size, total will, size, tip, size. Okay, so total numerical columns 3 and every two columns will create a plot. That is what is done by pair plot. When you want to see all of the relationship in a single graph, then you can use pair plot. This is very much used. Okay, because this is easy and you can visualize easily that what are the relationship. Okay, now if you want, you can give any hue parameter also. If I just give hue equal to 6, now see what happens. Color will be there. For male there will be different color, for female there will be different color. Clear? Or if I give hue equals to time, now see what happens. Okay, so lunch time, dinner time, this way also you can do. Clear? So this is what pair plot does. Now let's understand what is a joint plot. Joint plot means that will visualize the relationship between two variables along with their individual distributions. Let me show you this one. It is also very simple. A scatter plot between total wheel and tip. See, total wheel and tip with their individual distribution. Histogram. Histogram of total wheel, histogram of tips. Okay, so in a single plot, histogram is also plotted and scatter is also plotted. That is why this is known as joint plot. Okay, clear? So we have completed matrix plot and multiplot. Heat map, cluster map, joint plot, pair plot. Now let's understand what is regression plot. Now to understand regression plot, let me tell you one thing, that there is a machine learning algorithm known as linear regression. There we will understand this concept in details. But as of now, I will just give you a simple brief so that you can understand what is the basic and how we can use seaborn to do this kind of plot. Okay, let me tell you. Let's say we want to find the relationship between total bill and tips. We have some observed data, like this one is tips for this much of total bill, this one is tips for this much of total bill. Okay, so we have some observed data. Now our aim is that I know that for $30 total bill there is some amount of tips. For $40 total bill, some amount of tips. But my question is, what will be the tip? How much will be the tip for $35 bill? Now to answer this, we need to find a relationship between tips and total bill. So we want to draw a straight line by which we can get the answer. Like we will plot in this way, then we can find the tip if the total bill is $35. Okay. Now to find this straight line, we have to use linear regression algorithm. We will understand that in depth later. But for now, just understand that we have to find the straight line. This straight line can be this way, can be this way, can be this way also. So how will we find the best fit line? For that, we have to measure the errors. And what is the errors? Like see, if I predict that for $30 bill, this is the tip size. Okay. For $40 bill, this is the tip size. But the real tip may be different. So the real tip and the predicted tip. The real tip and the predicted tip, the difference between this are known as errors. And after we add all these errors, then we will measure that for which line the error is the lowest. And we will treat that line as the best fit line. Okay, so our job is to find the best fit line so that we can make a prediction based on total bill. Okay, so from the observed data, we will find the best fit line where the error will be less. Then we can predict how much will be the tip for a given amount of total bill. Clear? This plot is known as linear regression plot. That's what we can perform by C1. If you don't understand this as of now, just don't worry because this is a complete algorithm that we will learn while studying machine learning algorithms. But just know how we can plot this using C1 because that we are going to do later. So write SNS dot reg plot x equals to total bill y equal to tips. Data equal to tips. Just run it. Y equal to tip. Sorry. Okay, so you can see this is what we are talking about. This is the best fit line. Here, if I want to know for $25 bill, like this one, what will be the tip size? So we just can simply connect this and we can find the tip size. Clear? So this is the best fit line. These are the observed values, and from this line y equal to mx plus c, that is the formula of straight line. So we have to find m, we have to find the value of c. From where? From the observed data set. Okay, how to find? By calculating the errors. We will take only that straight line where the error is less. Okay, so this is simply regression plot. Okay, just have a basic idea. Don't go in depth for now. Okay, next understand linear regression plot. We can plot by LM plot also. Same, just let me show you. This is a figure level function. Now if I want, I can give hue equal to 6. Now let me run this one. Clear? Blue, male, red, female. Now let's apply some faceting on this. Like column equals to time. Now see there will be time, lunch, dinner. So two graphs, lunchtime, dinner time. Clear? Or if you want, you can facet row wise, lunch, dinner. Clear? Now the last one, that is residual plot. Residual plot means this will plot the residuals, the difference between the predicted value and the real value. Okay. Let me just copy this one and paste. I run it. Okay, so it plots the residuals between real data type and the predicted data types. So we have completed our seaborn tutorial. We have completed relational, distribution, categorical, matrix plot, multiplot, and regression plot. Okay, so we have almost done everything. Now, if you want to just decorate them, you can give X label, Y label, plot dot title, and we discussed about these things also. And we have already seen that seaborn has many advanced feature which Matplotlib does not have, but for in many cases, we have to use Matplotlib. Like you can see that we cannot plot pie plot using Seaborn. We need to be dependent on Matplotlib. Or if we want to change the name, if we want to decorate, then also we have to be dependent on Matplotlib function. Okay, so there are some advantages of using Matplotlib and some advantages of using Seaborn. So congratulations, we have completed Numpy, Pandas, Matplotlib, and Seaborn. Okay, we will meet in our next video. Till then, bye. Happy learning.